Hello everyone, I am Dr. Buddhika Liyanige. So today I would like to talk about quantum numbers. So let's go and find out what are the four quantum numbers with examples. Let's talk about four quantum numbers. The first one is principal quantum number. Principal quantum number values can be any integer starting from 1, 2, 3, 4 and so on. That determines the energy of the orbital. This is the structure of the atom, nucleus in the central, and then n is equal 1, n is equal 2, n is equal 3 and so on. Second quantum number is angular momentum quantum number. The symbol is Greek lowercase l. It tells us the shape of the orbital. S orbital L value is 0, P orbital L value is 1, D orbital L value is 2 and so on. The values of the L depends on the principal quantum number n. For example, for a given value of n, the possible values for L is driven from 0 to n minus 1. So lowest value always starting from 0 up to the n minus 1. For example, for n is equal to principal quantum number energy level is 2. The possible L values are starting from 0. 0 to n minus 1. 2 minus 1 is 1. So 0 to 0 and 1. For n is equal 4, the possible L values are 0 to n minus 1. 0, 1, 2 and 3. The next third quantum number is magnetic quantum number. This is ML. That describes the orientation of the orbital in space. For a certain value of L, there are 2L plus 1 integral values, the total number, 2L plus 1 total number of ML values possible. That is driven from minus L to plus L. Let's take example. L is equal to, L is equal to means you can remember it is for d orbitals. What are the possible ML values? The possible ML values from minus L to plus L. So minus L means minus 2, minus 1, 0, plus 1, plus 2. So minus L to plus L. The last or fourth quantum number is electron spin quantum number. We call MS. So MS can have two values, either plus half or the minus half. How we can say it's plus half and minus half? What is the meaning? So if the electron spinning is clockwise, then we call it is plus half. So when we indicate the electrons as arrows in an orbital box diagram, so we use up arrow. This is for clockwise spinning of the electron. The other electron is counterclockwise spinning of the electron. We indicate it as the down arrow. So when we are drawing the electrons, two electrons, paired electrons in one orbital, the one electron should be spin up, the other electron should be spin down. So these are the four quantum numbers. Now let's go and find out some possible examples. The first question is, an electron in an atom is in principal quantum number 3, n is equal 3 level. So list possible values of L and ML. So if n is equal 3, the possible L values are always 0 to n minus 1. So 0, 1 and 2. So what are the possible ML values? Each L value you all know, L depends on n, ML depends on L. So if L is 0, 0 to n minus 1, ML value is 0. If L is equal 1, minus 1, 0, plus 1. If L is equal to minus 2 to plus 2. Question number 2. What is the difference between 2px and 2py orbitals? So in n is equal to, there are 3 p orbitals. They are degenerate. That is the equal energy. All 3 p orbitals, they are equal size and the shape. The only difference is they are along the 3 Cartesian axes. If the p orbital, the dumbbell shaped p orbital along the y-axis, we call it is py. So the p orbital along the z-axis, pz, and along the x-axis, px. So that is the difference between px, py, and pc. So we use x, y, z to indicate the Cartesian axis. Next question. Given the values of quantum numbers associated with the following orbitals 2p, 3s and 5d. You can see the orbitals 2p, 3s, 5d, they are principal quantum numbers. In values are the front numbers given. This 2p means the principal energy level is 2. Principal quantum number is 2. 3s means principal quantum number is 3. And 5d is 5. What are the L values? L values, this is not all the possible L values. You need to find out what is the L value for this given orbital. P orbital, L value is 1. S orbital, L value is 0. D orbital, L value is 2. So ML values for these L values are minus L to plus L. So if L is equal to 1, ML values are minus L to plus L, minus 1, 0, plus 1. L is equal to 0, 0 ML value. L is equal to minus L to plus L, minus 2, minus 1, 0, plus 1, plus 2. Next, indicate the total number of p electrons in nitrogen, s electrons in silicon and 3d electrons in sulfur. So let's go and find out one by one. Nitrogen. If you write the electron configuration of nitrogen, atomic number is 7. So 7 electrons feed from low energy level to the highest high energy level gradually. So 1 is 2, 2 is 2, 2p3. So total number of p electrons. You can see only p electrons here. How many electrons? 3. So total number is 3. Next, silicon atomic number is 14. There are 14 electrons. 1s2, 2s2, 2p6, 3s2, 3p2. So the silicon is just below the carbon. The total number of s electrons. This is 1s2, 2s2 and then 3s2. There are 6 total electrons. Next, sulfur. Sulfur is atomic number 16. 1s2, 2s2, 2p6, 3s2, 3p4. There are 16 electrons. So total number of 3d electrons. So there is no 3d electron here because 3s2 after 3p completely failed and then jump into 4s. And after 4s, next highest is 3d. No d electrons in sulfur. So answer is 0. I hope now you will understand 4 types of quantum numbers: principal quantum number, angular momentum quantum number, magnetic quantum number and the spin quantum number and with examples. Thank you all for watching. If this is helpful, please subscribe to the channel and comment any specific area if you need to discuss in the future.